All right, for these four for the set, they're asking us to write the indicated form of the function. So in number 7, if you can squeeze in based on my work from the last one, they're asking us to write the piecewise for this. So I'm going to go ahead and write it over here. F of x equals, and we want two functions where for piece number 1, we need a slope and we need a point. And piece number 2, we need a slope and a point. So what's the slope doing in the first one? Do you see how it's going from a 9 to a 6? You got it. That's down 3, down 3, down 3. And so my slope of the first part is going to be that it's going down 3. And then the slope on the second part, do you see what happens? It's now going up 3. So picture a line that's going down 3 over 1, and then a line that's going up. So now that makes more sense. So the beginning slope of this function up here is going to start with a -3 and a 3. Now we need some sort of an HK, x1, y1, to put in as the point, x minus what, right? And so I need to look at this and identify where is the vertex of my absolute value function. Do you see how the graph is going down and then going up? Do you see the vertex? Good. There it is. The graph goes down until 0 and then starts going up. So that's my HK. That's my vertex. 2, 0 is what I'm going to plug into this function. So x minus 2 plus 0, not even needed, and x minus 2 plus 0. So there's my two functions of the piecewise function. We now just need to do the domain. So notice that it goes from -infinity all the way up until 2, and then from 2 until infinity. And we knew that because we knew that we were supposed to focus on this number anyways for our domain. So here I go writing the domain. It goes from -infinity up to 2, and then from 2 to infinity. And I'm going to include the 2 with the bottom function. Done. That's my piecewise for number 7. How'd you do? And by the way, the point that we used, that vertex we identified, was 2, 0 for both pieces. All right, the next one wants the absolute value function of this guy down here. So I'm going to write f of x equals, I need to get an a value, and I need the h and the k to plug in there. So let's go check it out. Up 1, up 1, up 1. Okay, a value is just 1, so I can leave it blank here, or I can write a 1, whatever you want to do. Let me squeeze this in better here. And then my point here is back 5, down 4. There's my vertex, my HK. Just not liking where I'm writing this. Hang on. So x minus a -5 minus 4. So why is it a plus 5? Because it's the opposite of back 5, and the -4 is there. So here's my h of my vertex, and here's my k of my vertex, and the a is 1, the parent stretch, and the orientation is up, so we just leave it invisible +1 in the front there. There it is, my beautiful absolute value function. Okay, this next guy, make a table of values. Be sure to include the vertex in the table. So right here's my h, right here's my k. That's where we want to start the table, at 6, -8, right there in the middle. So let's pick a couple points around it in the other direction, and a couple points around it in the other direction. So we want to start the table at the vertex in the middle, and then pick points around it. Okay, so from there, I'm literally just plugging in the inputs to get the outputs, and if I've done it correctly, this output should match this output, and this output should match this output if I've done my math correctly. So let's go do some math. And by the way, you can totally use Desmos to plug these in and do the work for you. But here's how it would go in our heads. X minus 6 minus 8. I'm asking you to plug in each of these input values. So first, let's plug in a 4. So 4 minus 6 is negative 2. Negative 2, absolute value of that is just going to be 2. 5 times 2 is just going to be 10. 10 minus 8 is 2. I just did the math. I could use Desmos, but I just did the math to get an output of 2. Let's go plug in 8 and see if we get the correct output of 2 for that as well. Let's go back up here and start again. Plugging in 8. Eight minus 6 is 2. Absolute value of 2 is just 2. 2 times 5 is 10. 10 minus 8 is 2. Hey, it worked. I got an output of 2 in both places. Must be right. All right, let's go input 5 to start, and then we'll test out 7. Inputting a 5. 5 minus 6 is negative 1. Absolute value of negative 1 is just 1. 1 times 5 is just 5. 5 minus 8 is negative 3. Let's go plug in and see if we get a negative 3 for the 7. Seven minus 6 is 1. Absolute value of 1 is just 1. 5 times 1 is just 5. 5 minus 8 is negative 3. Hey, it worked. I got the same output. Okay, so now that's all they asked me to do. Make a table of values and include the vertex. Yay, I'm done. Okay, if you're bad at this plugging in stuff I was doing right here, feel free to use Desmos to put in those inputs and check your outputs. Remember that there's a little button for the absolute value bars. Okay, last but not least, number 10, graph this function. Step 1 of every graph, label and scale your graph. 1, 2, 3, 4, 5 marker. 6, 7, 8, 9, really? 1, 2, 3, 4, 5 marker. 6, 7, 8, 9. 1, 2, 3, 4, 5 marker. 6, 7, 8, 9, and 1, 2, 3, 4, 5 marker, 6, 7, 8, 9. Okay, labeled and scaled, graph is ready to go. Before I can graph this, I need to identify the 2 crucial parts. Crucial part number 1 is my HK. Do you see it? Here's my little h staring at me. Remember, if it's a negative 6 in the equation, it's a positive 6 in real life. And here's my k staring at me right there. So 6, 4 is our starting dot, right 6, up 1, 2, 3, 4. Now picture this. This is going to be the graph of linear that's going down, negative 2/3 slope, and then graph of linear that then is going up. So it's going to be going down and then going up. It's going to be a V-shaped graph that's upwards orientation. So what is that slope? It's 2/3. So up 2, right 1, 2, 3. And on the other side, it's going to go exactly the opposite of that, reflected over to the other side. And we have space to go up, back 3, one more time, and then connect that graph with a straight edge. And she's done. All it asked was for me to graph it. I graphed piece number 2, and then I reflected and graphed piece number 1, and I'm done. I started, remember, start by getting the x1, y1 out of your equation, the 6, 4. Okay? How'd you do?